Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Today we will start the topic equilibrium, and we will try to find out what's the equilibrium, what is the meaning of equilibrium, what are the conditions under equilibrium. Starting from an example of daily life example. For example, if I'm gonna take this object and I place on the top of this whiteboard, and if this object is not in state of any kind of motion, for example, neither it is in state of translatory motion nor it is in state of rotatory motion, it means that this is in state of rest. In state of rest mean this is the state of physical balance. So starting from the definition, under the action of several forces, it means that if this object is lying on the table, it means that different forces are acting on this it means that the forces that you already know, the two common forces which are acting on an object is, one is the weight which is acting in downward direction, and the other one is normal reactional force which is acting in upward direction. It means that these are two forces acting on an object. It's not necessary that there must be two forces acting on an object. There may be more than two forces acting on an object. Review from the previous lectures, if we will take more than two forces. For example, if you push the box in this direction by applying applied force, and if the frictional force is observed in this direction, so there are four forces, the combination of four forces. But if the object or the box is still in state of rest, it means that this is in state of physical balance, it is in state of equilibrium. Starting from your book, here you can see that first, to avoid, because we want to achieve the static equilibrium. Static means the body is in stationary position, is in static equilibrium, right? So first, to avoid the translation, means the moving from one place to another place. The body should not move from one place to another place, it should be in state of rest. So the rest is the first main condition that the body must have. Secondly, follow your books, girls, and underline all these lines because they are important. Secondly, to avoid the rotation, we also have to avoid the rotation of this object. For example, if an object is in spherical or circular form, then you must avoid its rotation. It should not be in state of rotation. The net torque on an object must be zero. If the body is rotating, it means that it has torque. If there is no torque, net torque is zero, then the study of object in equilibrium is called static. And its definition that I already wrote here is that the state of body in which, under the action of several forces acting together, there is no change in translatory motion or translational motion as well as rotatory motion or rotational motion, is called equilibrium. So from here you can divide this concept into two parts, that for equilibrium we should avoid translation, we should avoid rotation. It means that the body should not move from one point to another point. If this is position A, this is position B, body should not move from one position to another position, and body should not rotate. For example, if this is a disc and this is position A and this is position B, it should not rotate anti-clockwise or clockwise. There must no any torque. So it means that this is the condition for equilibrium. Keep in mind, there is no specific rule to represent mathematically equilibrium. As you also know that couple also doesn't have any mathematical representation, so equilibrium also doesn't have any mathematical representation. It is just a concept that all the forces acting on a body must be equals to zero. If simply you want to observe this state, it means that the body is in state of rest, then the body must have certain conditions. So to find out the conditions of equilibrium, so what must be the conditions of equilibrium? Keep in mind, there are two conditions. You must have condition A and condition B. So condition A is known as the first condition of equilibrium. And the condition B is second. These are names. As it is, you have to write these names, right? Second condition of equilibrium. So these are two conditions for equilibrium. Keep in mind there is a very straightforward rule here. Avoid translation. This is actually first condition of equilibrium, and avoid rotation. This is actually second condition of equilibrium. In first condition of equilibrium, we will use the word forces. Forces should be equals to 0. And in second condition of equilibrium, to avoid rotation, it means that torque must be equals to 0. So it's very simple. I'm giving you the hint that to attain the condition of equilibrium or the state of equilibrium, you must have to avoid translation, you must have avoid the rotation. If you have to avoid the translation, it means that all the forces acting on a body is 0, and to avoid the rotation, all the torques acting on a body is 0, because torque will provide the rotational motion in an object. So according to this concept, this is known as the first condition of equilibrium, and this is known as the second condition of equilibrium. According to the first condition of equilibrium, see here, if at this position there is an object and several forces are acting on an object, F1, F2, F3, F4, F5. So if the body is still in state of rest, it means that sum of all the forces, when the vector sum of all, it's important to mention the word vector, because forces are vector quantities and we must follow the rules for the vector addition. You already know this. So the vector sum of all the forces acting on a body is 0. When the first condition of equilibrium is satisfied, mathematically F net is the sum of forces F1, F2, F3 and so on. It means that for the first condition of equilibrium, F net, what must be F net? If you are still confused that what is F net, what is sum of all the forces, just go through the lecture which is addition of forces, okay? And you will know that how all the forces are algebraically and also vectorially added. So if you have different forces, several forces are acting on an object. For example, if this on this object there are force F1, this is force F2, this is force F3, this is force F4, so many forces acting on a body. And if we sum up all the forces, if we add all the forces, for example, F1 plus F2 plus F3 plus F4, it means that if the body is in state of rest, the net force will be equals to 0. So summation of all the forces, if we will convert this equation into summation, it means that if there are more than 4 forces, you can also use the same logic, that F1 plus F2 plus F3 plus F4 plus up to so on up to Fn, and it must be equals to 0. If I want to combine all these logics in a single word, that is summation, and the mathematical representation of summation, because this force is vector quantities, so you must use the arrowheads at the top of this thing, okay? So here if you don't want to write all these forces, then just convert into summation. This symbol is for the summation, sum of all the forces. If there are I number of forces, I mean any number, I, j, k, you can use any word, okay? It's not a problem, is equals to 0. And from where to where this I should extend, starting point is 1, the ending point is n. So I should begin from 1 and I should end at nth position. So if you want to use this summation sign, you have to write like this. It will be we can read it as F net acting on a body when sum of all the forces starting from first and ending at end. Here you have to write the first first portion, and here you have to write the nth portion. So if sum of all the forces acting on a body is 0, then this is the first condition of equilibrium. And keep in mind, for the second condition of equilibrium, sum of all the torques acting on a body. For example, if the body is in state of rotation and this is force acting on a body, and this is momentum r, this is force, so this combination will make torque tau 1. If there is another torque tau 2, there is another torque tau 3, it means that there are so many torques. So sum of all the forces which are acting on a body is equals to 0, will give you no translatory motion. But what about rotatory motion? If there is sum of all the torques acting on a body, torque means tau net is equals to 0. So if we will expand, the tau net means that first torque plus second torque plus third torque plus up to so on up to nth torque, and if all these torques are 0, then how we will write it as? Then tau net will be equals to tau 1 plus tau 2 plus tau 3 plus up to so on tau n equals to 0. Then if we will follow the same step, we will use the word summation. Torque is also a vector quantity, so just use here arrowheads at the top of this. Okay, so if tau net is acting on a body is equals to sum of all the torques, ith torque, and I starting from 1 to I at end, it is equals to 0. So these are two mathematical condition for first and second condition of equilibrium. So just go through your book and equation number 4.8 and 4.9 and just give me the feedback, either you understand the logics or not.